Computers need numbers to process. And when we have to feed them words or sentences, we would like to convert them into numbers so that computers can understand them better. One of the simplest approach is that we find numbers that uniquely identify the words. So, we could give, let's say, a word like king, a number one, and so on. Um, this is a very crude approach, and if we consider that English vocabulary has 170,000 words, or some people claim 1 million words, we would need a number line up to 1 million. The other approach is that we take ASCII values of all the characters in the word, and we create a vector out of it, something like this, where the ASCII value of k is 107 and so on. This process is encoding. The result of this is that given this vector, all we can say is that given another vector, it is same or not, but we cannot say anything more than that. So it can only uniquely identify the words, but it doesn't say anything about semantics or the relationship between the words. That takes us to embedding. The term embedding is used because it implies the idea of placing or mapping words into this continuous vector space where their positions capture semantic relationships and contextual information. So we have a vector space of multiple dimensions, and we would like to take a word and put it as a point in that multidimensional space. And the line joining the origin and that point is the vector that represents the word. So let's do a recap. For machine learning algorithms to easily process words, we would like to convert the words into a series of numbers, and a series of numbers is also can be seen as a vector. So here is a simple example. If you have two dimensions, vector 7 7 is like this. Uh, and when we talk about words, the dimensions are lot many. In this case, 100 for example, but it could be 300 as well. And we want to represent each word as a point in that multi-dimensional space, represented by a vector which starts from 0 to that point. What we do is we start with loading a Word2Vec trained model, and this is one such pre-trained word vector model. Uh, Next thing we do is we try to find out what is the vector for king, and here we are showing that it's a this trained model basically supports vectors of length 100. So the king as represented by 100 numbers in 100, each on one of the 100 dimensions is like this. So this is the representation of king as per this Word2 vector. The next thing that we want to look at is similarity. So if there are two words which are similar in some way, they should be represented closer to in the multidimensional space. So for example, king and queen are kind of closer, and man and woman are also kind of closer. And also notice the direction, right? So it has to be that way. So the method for finding similarity is this. So we first tested with king. So the similarity between the two words, two same words, is 1, of course. And the reverse of similarity is distance. So the distance between these two points of these two words should be 0. So this is just for validating whether things are going fine. Now let's take some more examples. King and queen, the similarity is 0.75. Distance is 1 minus 0.75, so that's the number. Similarly, king and car, the similarity is 0.28. So what we see is that similarity of king to queen is much higher than king and a car, and which makes sense. Then we try to find out similarity between king and emperor, king and monarch, king and ruler, and they're all very similar to each other. Now we can also find out what are different words which are similar to king. Uh, the first thing that you try to find is the most similar word, and which looks like prince is the most similar word. So the idea is that words in the same context has more similarity. So for example, if we look at these two sentences, we see the words palace, guards, etc. in that sentence, and we see word king and prince. So we could say that king and prince have some similarity because they appear along with the same set of words in different sentences. Other words are queen, son, brother, monarch, throne, kingdom, father, emperor, etc. I don't know what is this I. Maybe two. Yeah. So this is about similarity. If two words are similar, then the vectors of them will also be closer to each other. Uh, One thing to understand is that the way this library works is that it it trained itself on huge amount of data, and when it finds the same word in similar context, it treats them as similar. So if in a particular sentence king appears and somewhere else with the same set of words in the sentence queen also appears, so the library, the training algorithm basically treats them as similar words, and they it gives them a point in that multidimensional space which is closer to each other. So that's one beauty of this embedding. The second beauty is the vector arithmetic. So remember, you could take a vector b, add a to it, and you would get this vector. And whether you did a plus b or b plus a, both will basically give you the same resultant vector. So let's do a very interesting arithmetic. So let's take king, let's remove man from it, the vector man, and then add a woman vector. And if we do this, you would see that the answer that comes for the resultant vector, the closest word that comes is queen. So basically this is saying that take king replaced with replaced man with women is the queen. Another, we use another similarity measure, but the answer is similar. Now one more thing, let's say we take four words and we want to find out which of them is the odd one out, right? So breakfast, cereal, dinner, lunch. This says that cereal is an odd one out, right? So it is also able to even find out which one is odd. Uh, Now let's see whether we can extend this to sentences. Here are two sentences. Obama speaks to the media in Illinois. The president greets the press in Chicago. Um, what we are doing is we are basically splitting them into list of words, and then we are asking a word mover distance to find out whether these two sentences are same or not. And you would see that with a very high score, it is saying that these two sentences basically are same. They are conveying the same meaning. Okay, so we talked about words having the same context, getting similarity, and sometimes words that go together also can have some similarity. For example, in this we have heard of stories which always start with once upon a time, and if you look at similarity of once and upon, we see that it has a high similarity. Although these are not synonyms, they don't mean same thing, but they kind of appear together. So there is some kind of relationship that is captured, and the relationship here is not about the same meaning, but the fact that there is a syntactic, relationship where they appear together with each other. So let's say we have to find antonyms. What is the way to find? The way is to use relationships or the vector arithmetic that we used earlier. For example, we want to find antonym of sad. We could say that sad minus bad plus good, which basically means that remove the bad from the sad and find the good. So it will take you to the opposite of sad. And if you see, the words are kind of antonyms of sad. Again, if we look at hot and cold, they are supposed to be antonyms, but their similarity is high. And the what is being captured here probably is the fact that they both talk about temperature, uh, and many times in sentences probably they come together, hot and cold, for example. Similarly, day and white. Another way to look at the arithmetic, vector arithmetic, is, let's say we want to find the capital of Japan. So what we do is we say that New Delhi, and remove India from it and add Japan to it, and it understands that the capital is uh, being talked about, and it finds the capital of Japan, which is Tokyo. This is a link to visualize Word2 vectors.